Okay, so here's some help answering the questions on VLANs. So I've drawn a diagram of the type of VLAN we want. As the question asked, it asked for 2 VLANs to be mounted on one physical LAN. So in this case, here's our physical LAN. We've got a wireless access point, a network switch, and to help us access the internet, we've got a router and a modem. So more about those later. Now, obviously, anything connected to the network switch is on the same LAN by definition. As long as it's in a local area, it's in LAN. If it's in the same network switch, it's on the same network. So we've got one physical network, but by creating 2 virtual LANs on the one physical LAN, we can have one network for public and one network for staff. Okay, so let's just revisit the questions. So a WAP will be required to allow users to connect. What does this stand for? Well, as I've just said, it's our wireless access point. So that's where things like laptops and phones and other mobile devices can connect to a network. The WAP will be shared by both VLANs. How will the restaurant ensure that the public know how to connect to the correct VLAN? Well, remember, each VLAN is invisible to the other. So if the restaurant log on to the network on VLAN 1, they could set up their wireless access point with the name Nando Staff, and that would be the wireless connection for VLAN 1. If they then connected and set up for VLAN 2, you could then set up a wireless network called Nando's Public on VLAN 2. So actually, although there's only one wireless access point, you can establish 2 separate wireless networks because there are 2 separate VLANs on the same physical LAN. So the public would know to connect to Nando's Public because you could give it a name, Nando's Public, so it'd be nice and clear for them by the name of the network where they need to connect. How can the restaurant prevent accidental attempts to connect wirelessly to the staff VLAN? Well, you can set wireless networks to be invisible. So another name for a wireless network name is an SSID. So you will sometimes see a setting that looks like this. Enable SSID broadcast. So if you broadcast the name of the wireless network name, people can easily connect to it. But if you don't tick that box and you don't broadcast the network name, people need to actually know it to be able to try and find it and search for it. So the best thing to do for a private Wi-Fi connection is to not broadcast the name, and by doing that you make the wireless network effectively invisible. So they could make the Nando's staff wireless network invisible. How can, so the WAP and restaurant office computer will both plug into the network switch. So what's the advantage of using a network switch rather than a hub? Well, this is just a thing about LANs generally rather than VLANs. Any messages, any packets that are sent on the network, if they're sent into a hub, they will be broadcast to every other device connected to the network. So if I wanted to send a request to the internet, in fact, if this was a hub, it would also be sent to the staff desktop PC as well as to the router and on from there. But if this was a network switch, then the network switch uses the MAC addresses to look at, right, where's the destination intended for these packets? Oh, it's that MAC address. Well, I'll just send it to the device with that MAC address. So network switches will route packets to the correct destination device. Hubs will broadcast packets to every device connected to the network, which makes a lot of unnecessary network traffic, and also is less secure because you're broadcasting data in the packets to every device on the network, which is undesirable, rather than just broadcasting it, just forwarding it rather to the device it's intended for. What tags will be required on the switch port where the WAP is plugged in and the switch port where the PC is plugged in? So here's the network switch, and these are the ports. So where the WAP is plugged in, we're going to have traffic from VLAN 1 and VLAN 2 coming in here. So this is going to have to be tagged for VLAN 1 and VLAN 2. On this port, where the PC is plugged in, there's only staff going to be using this, so it's only going to be people logging into VLAN 1. So this port can be tagged VLAN 1, and that will prevent any traffic from VLAN 2 ever going on this connection. So it keeps public traffic out of here and keeps it more secure. Explain how the VLANs improve security for the restaurant. Okay, so remember, what a VLAN does is it just basically splits the physical LAN up by tagging the ports and splitting it up to say, okay, I want that port to be VLAN 1, that port is going to be used by VLAN 1 and VLAN 2, that port's going to be used by VLAN 1 and VLAN 2. So you can split up your LAN into different LANs, and when they operate, they are completely invisible to each other, and they have their own security, firewalls and everything. So with VLAN 2 that I create for the public, I could set that network up so it requires no authentication at all on the wireless. So basically, you come along with your mobile phone, you could just connect straight away to a web page, and you might be asked to enter in a key that could be made available at a bar or in the shop. So you just enter the key, and that will allow you to use the internet connection. But effectively, you don't enter in a password, you don't enter in a username, you don't enter in a password. You're not an authenticated user of the network. So in effect, when you've got a public wireless network, you are not authenticated. Now, that is not what you'd want on the staff VLAN. You would want username and password. So the fact you can have separate authentication systems on each of the VLANs means that you can have a nice secure staff logon with username and password, and a more open, unauthenticated access to the public VLAN. So public do not have to be given a login for the staff network. And to explain that, each VLAN has got separate authentication. The public hotspot access is unauthenticated, no username and password. And of course, the staff VLAN, VLAN 1, would need a username and password. Now, reason 2, public will not have access to any resource on the staff network. Okay, so basically, if I connect to Nando's public, I'll be connecting to VLAN 2. Any sort of requests for information I try and send to the staff desktop PC, well, for a start, it won't even appear on the network, and secondly, no traffic at all will be allowed down VLAN 1 from any devices connecting on VLAN 2. They are not allowed. So basically, it keeps data and traffic separate on the two LANs, so the staff will not be able to accidentally access or even attempt to access any data on the staff network. So public will not have access to any resources on the staff network, e.g. private files. VLAN 2 traffic is blocked from the PC because the PC is on VLAN 1. What is required that all users can access the internet via a fibre optic cable. One advantage of fibre optic, well, is of course it is much faster than copper phone lines used by ADSL. And the two devices you need, well, One device is the fact that you're trying to connect to the internet. The internet is a separate network. To connect networks together, you must use a router. So the first device you will need is a router. So on one side of the router is your network, or in this case, effectively two networks, VLAN 1 and VLAN 2, two virtual networks. And on the other side of the router, you've got the wide area network, or the internet, if you like. So that's going to connect to your internet service provider. That connects to their network. So that's their network. This is your network, and the router is the thing that sort of routes packets from one network to the other. You cannot connect networks directly together. You have to go through a router. Now, the other thing you're going to need is a modem. The reason you're going to need a modem is because if that's a fibre optic cable going to your internet service provider, the thing coming out of your router is probably an Ethernet cable. Well, Ethernet cable carries electrical voltage signals. Fibre optics carry light, pulses of light. They're totally different. So the modem will sort of translate the outgoing electrical signals and make the light pulses, and also working the other way when you're downloading, it will take the pulses of light and convert them into the electrical signals. So basically, how the packets are transmitted is differently on a wire to a fibre optic, and it's the modem that sort of does that conversion from Ethernet to fibre optic and back again. So, of course, the last part of the question is to draw the network. Well, there it is. So feel free to copy it. So it's one physical network logically divided into two separate virtual local area networks. One for staff I could use and one for public. So that's more secure for everyone. So there you go.